The A380 holds 853 people at maximum capacity. Almost no airline has ever configured it that way. The plane that was supposed to reshape aviation has a stranger story than most people realize, and it starts with something as mundane as a coat of paint. 10. The paint job nobody talks about. Walk up to an A380 on the tarmac and you're looking at roughly 500 kilograms of paint. That's about the weight of a grand piano, just sitting on the outside of the aircraft doing nothing but looking like an airline's marketing department had opinions. That number sounds absurd until you start thinking about what it means operationally. Weight on an aircraft isn't just weight, it's fuel, and fuel is money. And on a plane that burns roughly 12,000 kilograms of fuel per hour, every kilogram you can strip out of the equation matters. Airlines spend serious engineering hours obsessing over seat foam density and galley cart materials. And then there's half a ton of paint. Airbus actually explored this. Some delivery configurations for the A380 feature unpainted undersides, bare aluminum on the belly, livery only where passengers and photographers will see it. The weight saving isn't dramatic in absolute terms, maybe 100 kilograms depending on configuration. But 100 kilograms held aloft for a 14-hour flight from Dubai to Los Angeles burns fuel you wouldn't otherwise burn. Multiply that across thousands of flights and the number stops being trivial. The reason the paint is so heavy comes down to surface area. The A380's wingspan stretches 79.8 meters, roughly the length of 9 London double-decker buses laid end to end. The fuselage is 2 decks high and wide enough that early passengers occasionally walked the wrong direction, looking for stairs that were on the other side of the aircraft. There is a lot of exterior surface to cover, and each layer of paint, primer, base coat, top coat, livery detailing adds up in grams that compound across hundreds of square meters. There's also a practical ceiling on how thin you can go. Paint on an aircraft isn't decorative in the way it is on a building. It protects the airframe from corrosion, UV degradation, moisture ingress. Strip it back too aggressively and you trade a fuel penalty for a maintenance cost. The engineers know this. They've modeled it many times over. The answer consistently is 500 kilograms, give or take, and that's where it stays. Which is fine. It's a solved problem. It just means that every A380 currently in service is carrying the rough equivalent of a small motorcycle strapped to the outside, painted in the colors of whichever airline had the most aggressive brand guidelines. The bare belly configurations never became standard. Most operators looked at the aesthetics, looked at the marginal fuel saving, and decided a half-painted Super Jumbo wasn't the image they were going for. So the full livery stayed. 500 kilograms. Flying daily. Completely unremarked upon by the 800 passengers sitting inside it. 9. The wings that were built to break. 79.8 meters tip to tip. That's the A380's wingspan, roughly the length of 9 London double-decker buses laid end to end and wide enough that several major airports had to physically rebuild their taxiways and gate infrastructure before the plane could operate there at all. But the number that matters more than the span is the flex. Under maximum load, the A380's wings are designed to bend upward by nearly 4 meters at the tips. 4 meters. That's the ceiling height of a reasonably generous room, happening in real time in the air, while 800 people sit inside reading the in-flight magazine. This isn't a flaw, it's the point. A wing that can't flex is a wing that accumulates stress at its root, rather than distributing it along the structure. Early aircraft engineers learned this the hard way. The A380's wing is built from a combination of aluminum alloys and carbon fiber composite materials with the flex characteristics engineered in from the start, rather than reluctantly accommodated. The result is a wing that moves like something alive, which sounds alarming until you understand that rigidity at that scale would be far more dangerous. The static load test for wing certification is one of the more visually striking things Airbus ever put on camera. Engineers loaded the wings to 150% of the maximum expected flight load, the regulatory threshold for certification, while high-speed cameras tracked every millimeter of deflection. The tips bent upward by something close to 7.5 meters before the test concluded successfully. The aircraft was on the ground. The wings were pointing almost toward the ceiling. They ran it past the certification point deliberately to find the actual failure threshold. The wings held, which, honestly, is not what you'd expect from something that looks like two slightly curved panels of metal attached to a tube. The winglets at the tips are a separate detail worth a second. Each one stands about 3.8 meters tall, roughly the height of a two-story building's exterior wall. They're not structural in the load-bearing sense. They exist to reduce induced drag by controlling the vortex that forms at the wingtip during flight. Remove them, and the fuel burn goes up measurably on every single sector the aircraft flies. On the A380, everything at scale has a consequence. A few degrees of wing geometry affects thousands of liters of fuel annually. A meter of wingspan required renegotiated airport contracts across 3 continents. The flex test footage exists, it's publicly available, and it still looks like a mistake is about to happen right up until the moment it doesn't. 7.5 meters of upward deflection. Still attached, still certified, the cameras kept rolling. What's at number 8? The tail tank that flies the plane. Before the first passenger boards, before a single bag is loaded, the A380's fuel system is already making decisions. Not a crew member. Not a computer in the traditional sense of the word, though there is one involved. The aircraft's fuel management system is actively moving weight around inside the plane to keep the center of gravity where it needs to be. And one of the tanks doing that work is buried inside the horizontal tail, 3 stories off the ground at the back of the aircraft. There are 11 fuel tanks in total across the A380. Most of them live in the wings, which is standard for large aircraft. The wing tanks hold the bulk of the fuel. The A380 can carry approximately 320,000 liters when fully loaded, which is roughly equivalent to filling 4.5 standard suburban swimming pools. That number alone tends to stop people. The tail tank is different. It holds far less than the wing tanks. Its primary job isn't storage, it's balance. During cruise, the fuel management system pumps fuel into or out of the tail tank to shift the aircraft's center of gravity slightly aft, toward the tail. This sounds counterintuitive until you understand what it does aerodynamically. Moving the center of gravity rearward reduces the load on the horizontal stabilizer, which reduces drag, which reduces fuel burn across the entire flight. A small weight shift in the tail produces a measurable efficiency gain over 14 hours in the air. The system does this continuously and automatically. Pilots can override it, but under normal operations, they don't need to. The plane is essentially trimming itself in real time by redistributing several tons of fuel between tanks without the crew doing anything at all. 11 tanks. Active fuel transfer mid-flight. A tail assembly that participates directly in fuel economy. None of this is visible from a window seat. You're sitting above the wing, watching a film, and several meters behind you, a pump is quietly moving fuel around to shave fractions of percent off the drag coefficient. The engineers who designed this spent years on the aerodynamic modeling before a single tank was built. The efficiency gains compound. Less drag means less fuel burn. Less fuel burn means a lighter aircraft. A lighter aircraft needs less thrust. Less thrust means quieter engines and lower emissions per seat. The tail tank idea wasn't unique to the A380. Airbus had used similar systems on earlier wide-bodies. But at the scale of the A380, with its enormous fuel load and long-haul mission profile, the gains were proportionally larger. A fraction of a percent efficiency improvement across 320,000 liters of fuel is not a small number. 320,000 liters, redistributed continuously, without you noticing. Alright, number 7. The quietest super jumbo nobody expected. London. Heathrow, sometime in the mid-2000s, was one of the most politically charged airspace conversations in Europe. Residents under the flight path had been fighting noise for decades. Local councils had noise monitoring data. MPs had constituents who couldn't sleep. And then Airbus introduced a plane carrying twice as many people as the 747. And the noise footprint shrank, not by a little. The A380's noise contour at Heathrow, the measured area on the ground exposed to significant aircraft noise during approach and departure, was smaller than the 747's. An aircraft that weighed more, carried more, and displaced more air was somehow quieter to the people living underneath it. The engine technology is most of the explanation. The A380 uses high bypass turbofan engines. The Rolls-Royce Trent 900 or the Engine Alliance G P7200, depending on the operator, with bypass ratios that move a large volume of air around the core rather than purely through it. More bypass, lower jet velocity, less noise. The physics is straightforward. The scale of the achievement at this size of aircraft is less so. There's also the approach profile. The A380 is heavy enough that it maintains a relatively stable, continuous descent rather than the stepped, thrust-on, thrust-off approach that older heavy jets used, which generated noise spikes every time the engine spooled up. The A380 tends to come in cleaner, steadier thrust, less variation. The noise curve flattens. If this is the kind of thing that gets you, drop a like, leave a comment. It genuinely helps. Now, back to it. Airports that had initially resisted the A380, worried about infrastructure costs and noise objections, found themselves in a different position once operations began. Some that had negotiated noise curfews and slot restrictions based on existing aircraft performance found the A380 came in under their own thresholds. A few operators used this to argue, with some success, for additional slots. An aircraft so large it was initially seen as a noise problem had become, in certain regulatory conversations, the quieter option. The cabin pressure is part of this story too. Airbus pressurized the A380 cabin to the equivalent of 6,000 feet altitude rather than the 8,000 feet standard on most commercial aircraft. Lower cabin altitude means more oxygen density, less passenger fatigue, fewer headaches on long-haul flights. It doesn't affect external noise at all, but it was a deliberate decision backed by passenger physiology research to make the experience of sitting inside this particular aircraft measurably better than the industry standard. Airbus ran studies. Passengers reported feeling better after long A380 flights than equivalent long flights on other aircraft. Airlines use this in marketing. The plane that was too big for most routes, too expensive to fill, and logistically complicated to operate was, by two distinct measurable criteria, more pleasant than what it replaced. Nobody really led with that, but the data was there. The sixth attempt. Hamburg and Toulouse couldn't agree on a wire. Not metaphorically. Literally, the physical wiring harnesses manufactured in Hamburg would not fit into the fuselage sections assembled in Toulouse. 600 kilometers of wiring per aircraft routed through a structure built on two sides of a continent, designed using different versions of the same software. One team had upgraded their CATIA design software, the other hadn't. Nobody had caught the version mismatch before metal started getting cut. The discovery came during final assembly. Technicians in Toulouse tried to install wiring looms that had been built to a slightly different digital model and found they were too short. Not by a lot. Enough. The scale of the problem compounded fast. This won a single harness on a prototype. Airbus had already committed to a delivery schedule, taken deposits, and publicly announced entry into service dates. Airlines had built crew training programs around those dates. Singapore Airlines had marketed its A380 launch as a flagship event. The gap between what Hamburg had built and what Toulouse needed wasn't just a manufacturing error. It was a cascading schedule failure affecting dozens of committed customers and billions in contracted revenue. Airbus announced delays in June 2006, then more delays in October 2006. The total program delay eventually stretched to nearly 2 years beyond the original target. The cost, restructuring charges, penalty payments, lost orders, reached approximately 6 billion euros, which is roughly the GDP of a small European nation, spent correcting a software version control failure. 2 CEOs departed. Gustav Humber left in 2006. His successor, Christian Streiff, lasted less than a year before Louis Gallois took over and began the restructuring program that became known internally as Power 8. Power 8 involved cutting thousands of jobs, selling assets, and reorganizing the entire production system to prevent the Hamburg-Toulouse split from creating this kind of failure again. The wiring problem was fixable, in the end, by hand. Hundreds of technicians worked around the clock in Toulouse, manually rerouting and lengthening harnesses that should never have needed touching after leaving the factory. Picture that. A plane that costs around $300 million per unit being corrected with human hands, millimeter by millimeter, in a hangar the size of several football pitches, because two computers weren't running the same version of the same program. The engineers who built the wiring were not incompetent. The systems that allowed two facilities to drift out of sync were the failure. Large-scale distributed manufacturing across national borders, with production split for political and economic reasons as much as logistical ones, had introduced a fragility that only became visible at final assembly. The worst possible moment to find it. Airbus restructured. The A380 eventually entered service with Singapore Airlines in October 2007. The plane worked. The wiring fit. It had taken roughly 1,000 extra workers, 6 billion euros, and 2 leadership changes to make it fit. Consider number 5, the air you breathe on board. Sealed inside an aluminium tube at 38,000 feet, the air around you is not actually the air outside. It's either bled from the engines or, on newer aircraft, mechanically compressed and filtered. On most commercial jets, the cabin is pressurized to the equivalent of 8,000 feet altitude. That's roughly the elevation of a mountain town in the Rockies. Not dangerous, not comfortable, either. The A380 does something different. Airbus pressurized the cabin to the equivalent of 6,000 feet, 2,000 feet lower than the industry standard, which in physiological terms means meaningfully more oxygen density in every breath you take during a 14-hour flight. 2,000 feet of altitude difference doesn't sound like much. Put it another way. At 8,000 feet equivalent, your body is working slightly harder to extract the oxygen it needs, your sinuses are under pressure, and the dry recycled air is pulling moisture from your respiratory system continuously for the duration of the flight. Multiply that across 10 or 12 or 14 hours and you arrive at the destination feeling like you've been slowly wrung out. Most people assume that's just what long-haul flying feels like. Airbus ran studies. They weren't small studies, and the methodology was specific, measuring passenger-reported fatigue, headache frequency, and general well-being after long-haul flights on the A380 versus comparable flights on other wide-body aircraft. The results showed measurably lower fatigue scores and fewer headache reports on A380 sectors. The company published the findings. Airlines use them in marketing materials for their A380 routes. The humidity management is a separate layer of the same decision. Lower cabin altitude makes it marginally easier to maintain slightly higher humidity without causing condensation problems inside the airframe structure. The A380's composite and aluminium structure tolerates this differently than older all-aluminium designs. The result is air that feels less desiccating over time. Still dry by any normal standard, but less punishing across a Sydney to Dubai sector than what passengers on older aircraft experience. None of this required a breakthrough. The technology for lower cabin altitude has existed for decades. The reason most aircraft use 8,000 feet rather than 6,000 is structural. Maintaining lower cabin altitude means the fuselage skin is working against a larger pressure differential, which means either heavier structure or more frequent inspection cycles. Airbus engineered around this on the A380 with a fuselage cross-section and wall thickness that could sustain the lower altitude without a prohibitive weight penalty. The decision was deliberate. It cost something in structural weight. Airbus decided the passenger experience benefit was worth it. Emirates, which operates by far the largest A380 fleet in the world, over 100 aircraft at the program's peak, specifically marketed its A380 routes on the wellness angle. Longer sectors, better air, arrive in better shape. For a carrier whose entire network strategy revolves around long-haul transit through Dubai, this wasn't a marginal selling point. The plane was pressurized differently than everything else flying at the time. Passengers mostly didn't know. They just felt slightly less destroyed when they landed. The fourth order collapse. One airline held the whole program together. Emirates placed its first A380 order in 2000 and kept ordering through the delays, through the wiring crisis, through 2 CEO departures, and through a global financial crisis that caused several other carriers to quietly let their options expire. At the program's peak, Emirates had committed to over 160 aircraft, more than half of all A380s ever ordered by any single customer. Not a plurality, a majority. One airline based in one city was the financial spine of the largest passenger jet ever built. This was always a structural risk. Airbus knew it. Industry analysts wrote about it. The dependency was visible from the outside, and yet the program continued because the alternative, acknowledging that no sufficiently broad customer base existed to justify the aircraft, was not something Airbus was prepared to do while deliveries were still happening and Emirates was still signing. The relationship had logic behind it. Emirates' entire network model is built around a hub and spoke system through Dubai, connecting secondary cities across Europe, Asia, Africa, and Australia to each other via a single transfer point. For that model, you want the largest possible aircraft on the trunk routes, the ones between Dubai and London, Dubai and Sydney, Dubai and New York, because those routes have the demand density to fill a very large plane. Emirates wasn't buying A380s as a prestige gesture. The aircraft genuinely fit the strategy. Picture the terminal at Dubai International during peak hours, gate after gate occupied by Emirates A380s, each one carrying between 400 and 500 passengers in standard 3-class configuration, cycling through a hub that processed over 80 million passengers a year at its pre-pandemic peak. The A380 wasn't just an aircraft type in the Emirates fleet. It was load-bearing infrastructure. Then, in February 2019, Emirates President Tim Clark gave Airbus an ultimatum. Unless Airbus committed to developing a new engine option for the A380, something that would improve fuel efficiency and extend the aircraft's commercial viability against the newer Boeing 787 and Airbus A350, Emirates would reduce its outstanding order significantly. Airbus couldn't find another anchor customer to absorb the risk. They looked. The conversations happened. Nothing materialized at the scale needed. 14 days after Emirates' position became public, Airbus announced it would end A380 production. The decision was framed carefully. Production would cease in 2021. All existing orders would be fulfilled. The program had run its course. The language was composed. The timeline was not. From Emirates' public signal to Airbus program cancellation announcement took less than 2 weeks. An aircraft program that had cost an estimated 25 billion euros to develop, that employed tens of thousands of people across 4 countries, that had taken 12 years to go from launch to the end of the production line, ended in a fortnight because one customer changed its mind about future orders. Emirates still operates the aircraft. Hundreds of A380s remain in daily service. The last one was delivered. The line is cold. 25 billion euros. One customer, 14 days. 3. The ghost fleet nobody planned for. March 20. Borders closing, governments grounding flights, passenger numbers collapsing towards zero in a matter of weeks. Airlines parked aircraft wherever they could find space. Airport aprons, maintenance bays, remote desert storage facilities in the American Southwest and the Spanish interior where dry heat and stable conditions slow corrosion. Some aircraft went in with the expectation of returning to service within months. The A380 has specific problems when it sits idle that smaller aircraft don't face at the same scale. 4 engines, not 2, each requiring preservation procedures, sealed intake covers, oil circulation protocols to prevent bearing damage. 16 main landing gear wheels, each with brake assemblies that develop flat spots on the tire if the aircraft isn't periodically moved. A pressurization and air management system that needs to cycle or degrade. The bigger the aircraft, the more there is to keep alive when it's doing nothing. Storage crews at facilities like Teruel in Spain or Victorville in California worked through fleets of parked wide bodies during the pandemic. running maintenance rotations on aircraft that weren't flying. For A380s specifically, the work required was significant enough that some airlines began running the numbers on return to service costs and comparing them to the aircraft's remaining useful life and residual value. The math didn't always work out. Air France retired its entire A380 fleet during the pandemic. 9 aircraft, some barely a decade old, gone without returning to service. Lufthansa announced accelerated A380 retirements. Thai Airways, already in bankruptcy proceedings, never brought its fleet back. Qantas parked its A380s in the Californian desert at a facility specifically suited to long-term aircraft storage, and held them there while it assessed whether refurbishment costs were justified given the aircraft's age and the changed economics of its network. A decade old and being evaluated for retirement. On a plane built to last 35 years with proper maintenance. The economics of the A380 had always been tight. The aircraft carries enormous numbers of people, but it needs enormous numbers of people to break even. The per-seat cost is only attractive when the cabin is full or close to it. Airlines that operated the A380 on routes with sufficient density found it worked. Airlines that had stretched to justify the purchase or whose networks changed found themselves holding an aircraft that required specific high-volume routes to justify its operating costs and couldn't easily be redeployed elsewhere. A twin-engine widebody, a Boeing 787 or an Airbus A350 can fly thinner long-haul routes at a profit that an A380 can't match on the same sector with fewer passengers. The pandemic didn't create this problem. It accelerated a reckoning that was already forming. Dozens of A380s in desert storage during 2020 and 2021 represented the collision of two separate realities. An aircraft optimized for a world of hub-based mass transit, grounded during a period when mass transit had simply stopped. Some of those aircraft flew again. Others were assessed, found wanting, and quietly handed to dismantling facilities. Aircraft that had been delivered within the previous 8 years, disassembled for parts. The serviceable components, engines, avionics, landing gear assemblies went back into the supply chain. The airframes went to recycling. The average A380 that didn't return from pandemic storage had logged somewhere around 45,000 flight hours in a design lifetime of around 150,000, not even a third of the way through. 2. The last delivery. The Cold Line. Hamburg, April 21. The final A380, MSN 272, registered A6EEV in Emirates livery, rolled out of the Airbus facility and was handed over to its operator. No fanfare proportionate to the occasion, a delivery ceremony as there always is, with handshakes and a symbolic key and photographs. Then the aircraft taxied away and the production line behind it stopped. Not paused, stopped. The tooling that built the A380's fuselage sections, the jigs, the fixtures, the specialized equipment designed specifically for an aircraft with a cross-section that exists nowhere else in commercial aviation, was not mothballed in any meaningful sense. Some of it remains in place. Some of it has been repurposed or scrapped. The infrastructure assembled across 4 countries to build 251 aircraft over roughly 15 years has no obvious second act, because there is no aircraft it was built to build except this one. 251 aircraft. Total. For context, Boeing has delivered over 10,737 variants since the type entered service. The A380 production run across its entire existence amounts to a rounding error in the 737's delivery history. At that scale, the tooling investment, the airport infrastructure upgrades, the supplier network built around a production rate that peaked at around 30 aircraft per year, all of it existed to serve a program that delivered fewer aircraft than some narrow-body types deliver in a single calendar year. Airbus never officially acknowledged a break-even number for A380 production, but analysts consistently estimated it at somewhere between 400 and 700 aircraft, depending on assumptions about development cost amortization. The program delivered 251. Even the most optimistic accounting never got close to recouping the development investment from aircraft sales alone. The commercial logic was always partly downstream, in parts, in maintenance contracts, in the positioning of Airbus as a manufacturer capable of building at the largest scale. Some of that holds. Airbus is still here. The A350 and the A330neo are selling. The company absorbed the A380 loss and continued, but the line is cold and no successor is planned at this size. Boeing's proposed new large aircraft studies, the various concepts sketched out over the years for something beyond the 747, haven't materialized into a program. The market consensus, such as it is, has settled around twin-engine wide-bodies in the 250 to 400 seat range as the optimal unit for long-haul flying. Hub and spoke at the scale the A380 was built for has given way, commercially at least, to more direct routing on more efficient twins. The aircraft still flying, and many are. Emirates operates well over 100 daily, will keep flying for years. Some will reach their design service goals. Some will be retired earlier as maintenance costs compound against residual value. The last one will eventually be parked, then disassembled, then gone. There are no orders pending. There is no production slot to fill. Airbus has confirmed repeatedly and without ambiguity that the line will not reopen. The tooling is still there. The line is cold. 251 aircraft total, ever. And the last one was delivered on a Tuesday in April 2021 with a handshake and a photograph. 1. Somewhere above the Indian Ocean, right now, an A380 is probably in cruise. Emirates flight most likely. 800 passengers or close to it distributed across 2 decks, sitting above 4 engines burning through fuel at a rate that would empty a standard backyard swimming pool every few minutes. The aircraft is doing what it was designed to do. It is doing it well, and there is no replacement coming, not from Airbus, not from Boeing, not from anyone currently in the business of building commercial aircraft at scale. The question of whether a passenger jet larger than the A380 will ever fly again, not a prototype, not a concept, but a certificated aircraft carrying paying passengers in regular scheduled service, has no answer that anyone in the industry is willing to give with confidence, because the answer is almost certainly no. And saying so out loud requires acknowledging something uncomfortable about where aviation went. The A380 was built on a theory. The theory was that air travel would continue to grow along the hub and spoke model that had defined long-haul aviation since deregulation, that passengers would flow in large numbers between major hubs, and that the most efficient way to move them was in the largest possible aircraft. Bigger planes, fewer movements, lower cost per seat. Airbus modeled this carefully. The projections were not invented. The logic was sound given the data available at the time of the launch decision in the late 1990s. Boeing looked at the same data and reached a different conclusion. Their bet was on point-to-point routing, that passengers wanted to fly direct between secondary cities rather than transit through hubs, and that twin-engine aircraft with sufficient range to fly those routes economically would define the next era of long-haul travel. That bet became the 787 Dreamliner. It entered service 4 years after the A380. It has now been ordered by over 70 airlines. Production continues. 2 competing visions of how aviation would develop. One of them was right. The A380 isn't a failed aircraft. It's a precise aircraft. Precise in the conditions it requires to work economically. And those conditions are narrower than Airbus anticipated when they committed 25 billion euros to building it. It needs high-density routes. It needs hub infrastructure. It needs an airline willing to fill 800 seats on the same city pair, day after day, with enough frequency to justify the gate allocation and the crew training and the maintenance contracts. Emirates built its entire network around those conditions. It worked for Emirates. It didn't work broadly enough to sustain a production line. The aircraft that pioneered lower cabin altitude, active fuel transfer through a tail tank, wing flex engineering at a scale never previously attempted in commercial aviation, and a noise footprint smaller than the aircraft it replaced. That aircraft is now in managed decline. Not sudden, not dramatic, just the slow arithmetic of retirements outpacing the 0 new deliveries. The last A380 ever built is already flying. It has a registration number. It has a crew. It has a schedule. somewhere over the Indian Ocean, right now. No replacement behind it.